We are live.
Ladies and gentlemen, a very good evening to one and all present here. I am Vinayak Sharma, a core member of AWS User Group Dehradun, and I am thrilled to welcome you to day 8 of our AWS Generative AI Bootcamp. As we have completed most of our journey, it has been incredible. On July 12th, we had an enlightening session in which we learned about image generation using Amazon Bedrock. Today, we promise to deliver even more as we delve into the crucial topic of conversational AI and chatbots. Also, we will be announcing the best performers till day 6 in today's session. So stay tuned and engaged. Thank you all for joining us on day 8. Your presence here reflects your commitment to learning and exploring the cutting edge technologies in AWS and generative AI. Today, we are honored to have Pallavi Srivastava with us. Pallavi is a senior cloud support engineer at Amazon Web Services. She specializes in serverless and containers, Kubernetes, IoT, AI, and edge computing. Her extensive experience and expertise will provide us with valuable insights into building advanced conversational AI systems. Today, we have an exciting agenda lined up. To kick off, she will begin with insightful discussions on these advanced techniques. Adding to it, we will learn how to utilize AWS tools effectively for building conversational AIs and chatbots. I request you all to stay engaged and participate actively throughout the session and secure a chance to win exciting rewards. Now, without any further ado, I request Ms. Pallavi to address and start. Let's get started. Stage is all yours.
Thanks a lot, Vinayak, and welcome everybody on this session and staying throughout this learning series on Gen AI. I'm very happy to be here, and I'll quickly start with my introduction. My name is Pallavi Srivastava. I'm senior CSE here at AWS. As Vinayak mentioned, I have worked on multiple domains within AWS and on multiple AWS services. I joined AWS around I think 7.5 years back um, in 2016, and since then I've been working on different services. I've worked on IoT services, now GenAI services as well, and Lambda API gateway, which are part of serverless, as well as SQS, SNS, and container services like EKS and ECS too. I'm very much interested in public speaking and conducting tech workshops, hackathons, and all. And I think that's one of the reasons why I'm here today to share my knowledge around conversational bots with you all. Looking at the agenda for today, what we have is we are going to discuss about generative AI and why it matters in conversational AI. So yes, there are different things which we are going to talk about. We have a basic introduction around Amazon Lex, that is another conversational AI service, and what are the new generative AI features we have in Amazon Lex. A bit about RAG and knowledge base integration with Amazon Lex. I know that we had previous sessions where we have already covered a bit of RAG, knowledge bases, Bedrock, and stuff, but we're just going to revisit that and look how it is being integrated with Lex. A quick demo and a workshop walkthrough, and then we'll proceed to Q&A. But even in between the session, if you have any kind of questions or have any doubts, feel free to post those in the comments. And as and when we'll read the comments, we'll go ahead and clear your doubts. Okay, let's get started. The main question right now, I think the reason why we are all here and to understand more is about generative AI, right? You all might already know that generative AI is actually used to create a lot of new content, right? It's kind of making the mundane task fully being automated and creating a lot of automations using chatbots, using virtual AIs and stuff. So creating these kind of new edge applications is what um, we call generative AI. And how it works is it is powered by the large models, the foundation models, which are pre-trained on a vast amount of data. So consider it as Earlier we used to train a lot of different models. We need to get access to a lot of data to train our models and then go ahead and start working on them or using them in our applications. Now with the advancement of generative AI, we already have access to a lot of different models present out there, and we can very easily connect to those models, use the features which are provided by those models, use the actual AI ML foundations there in our applications. So that's what generative AI is all about. A quick brief about foundation models. So when we talk about traditional ML models, right, you can see that we used to work with labeled data, right? And we used to create labeled data for different use cases. For text generation, we used to create different. For Q&A, different. For chatbot, we used to build it in a different format. So first step was to train, then to deploy, and then to use it and integrate it in applications. But with the advancement of foundation models, we can also use unlabeled data, put it in foundation model, pre-train it, and then use it to perform the task. So a single model can be used for different tasks, right? Like text generation again, summarization, image generation, information extraction, sharing some more like paragraph summarization, creating new documents, and a lot of different things. What we are going to discuss mostly about is chatbot and how conversational AI is coming into picture here. You should also know what are the different types of foundation models. So when we talk about inputs, so the input can be different. It can be a group of text or a single keyword, or a whole image. So the inputs can be different. For example, let's say if the input is a text and you just want to convert it to another text, so it can be text to text foundation model which we need to use. Let's say if we want to just create embeddings is something which we use in a database to match correctly and then create the output of an LLM, right? So if we want to use text to embeddings, then the input might differ. Or let's say we want to generate an image. For example, if you can see on the screen, we're just trying to create a photo of an astronaut riding a horse on Mars. So this includes two things. First, we'll need to analyze what input or what is the semantics around it, or what is the input trying to achieve. And then we have to generate an image as well. So we have to identify different keywords within it and then try to create a new product or image as such. So that is called multimodal. So there are different types of foundation models which you will use throughout your GenAI learning series. Next, we have conversational AI, right? So what is conversational AI? When we say that we want to have a bot provide us responses as a human. Okay, right now, what we used to do is like, or I should say earlier, what we used to say is, we had very rigid responses. We used to say, create a phone call for me or give me a number associated with this name. So then we used to get the response, but that was already present somewhere. We had already given a complete you can say prompt, a complete list there. It was just fetching that and giving the response. So that was very transactional based, so it was not very, you can say, conversational or human like interaction with the bots which we used to do. But now, with the advancement of Gen AI and using these foundation models, what we can do is we can build conversational AI. So that's actually using generative AI to build intelligent bots or build conversations which are easily modifiable. So that's what conversational AI is all about. And it can be informational, it can be of different types, right? For example, the first one can be informational, just to understand where, let's say, my order is. Let's say you have a bot for a food vending service or application, and you're just trying to understand where your order is. So that will be kind of informational message. Then it can be data capture. For example, you are providing some details to your consumers, to your customers. So then it would be data capture ways, like when would you like to book an appointment, or we are trying to get particular data from the user. In this case, transactional, that transfer $100 to someone or to this account. So that will be a transactional based, where we are actually asking them to perform an operation. So an operation will be performed at the back end, but a conversation has to begin from somewhere, right? Or it can be proactive as well. Like, let's say there has been some operation which we are doing on our banking app, and suddenly we get a pop-up that you were trying to do this and it was not done, so do you need any help? So those kind of conversations can be automatically initiated, and we can keep a check on how what the prompts are. Prompts is something which is the input which you provide while you're talking to a bot. Okay, so that's how it goes on, and the list goes on, and that's what conversational AI is all about. So it means that we are using natural language and self-learning systems to create a balance and to talk to the end user. So we are giving that kind of you can say skills to a particular chatbot and using conversational AI. What can be the interface? So there can be multiple interfaces when you're talking about conversational AI, right? So it can be via phone call. So let's say you are running a customer care center and you would like to have an interface where you are calling an IVR, and you want that IVR to change responses based on users input. So that's also one kind of interface where you can use conversational AI. Then definitely we have text and SMS. You are sending some messages, and based on messages, it's basically changing the output based on the previous input given by the user. For that, we generally use Lex and pinpoint services. Then we also have web-based chatbot, where we are actually going to see today that we will build a chatbot and how we are interacting with that chatbot, how automatically responses are being generated. So that we will do using Lex service. You can also integrate Lex with any other platforms like Facebook, Messenger, or any other, and then um, deploy your bots there and use the other kind of data which you want to provide. Feel free to post any questions in between as well on the chat, and I can answer them as I see them. Okay. Now, how can you use conversational AI? So, generally, it can be done on contact centers, as I mentioned, using Amazon Connect. You can have Lex integrated with Amazon Connect, create those bots and do it. Then you can create informational bots where you are just creating a bot for your own. You can say if your class is using a kind of resources, right, and you just want to create a bot so that anyone who just ask a question on the bot, they will be able to send a reply, right? So you attach some of the documents references there, create a bot, ask a question, it will fetch the responses from the information which you have already provided or pretend, and then will give the response. So informational bots are very much common these days as well, and many companies are actually trying to integrate these bots to improve the efficiency of the employees. Then we also have enterprise productivity bots, like can I help you get more done? So let's say you want to create some graphs, you want to analyze some data. For that also you can create these chatbots using conversational AI. What it will do is it will fetch the information which you have already provided. We will see in some time how we can integrate knowledge bases in Bedrock, and let's say you have PDF files which has a lot of information and you want to integrate that with your chatbot, and when you ask a question from the chatbot should be able to fetch the information from those PDF files and return the response on the chat. So those kind of things can be very easily done. So you just have to think about a problem and just start implementing it. You can just think of, let's say, um, there is a very big chapter around a specific topic, right, which you are learning right now, and you want to integrate that and several other chapters like that with a bot, and you're creating a knowledge bot or ask me a question bot, where you just ask a question and that bot will just fetch the data from those different chapters and give you the response. Okay, what happened on 18th of July, or what happened on 17th of October on this year on this day? So all those things you can do while creating a conversational bot. Now, how we are integrating AI and solving these problems is the traditional ways of creating chatbots. There were manual efforts needed, because all those bots were actually just trying to navigate to a user at the end. right? Because if the answer is not present there, we have to reach out to a actual user or an agent at the backend, and that agent will send the responses in that case. But let's say you want to automate this, so it was very difficult that time. And the whole infrastructure that way was subject to very long wait queues. The agents were limited, then multiple transfers had to be done. So automatically, if you want to do these things, it was not possible. And let's say there was a high number of calls and the live agents present were less, so how will you answer those all those calls, right? So it's very important these days to have a conversational bot or an IVR system which can easily understand the customer queries. And even if the data is not present in the existing references, it can fetch the data using generative AI and LLM models from different sources, which you already provide them while creating these chatbots, and can respond back. So now you can use services like Amazon Lex, Kendra, Poly, and even the Chime SDK. And you can use these services and then create the bots, which will be able to reduce the overall wait time. Will have like 24 by 7 by 365 days presence. Routing to the right agent will be very faster. Automatically, it will identify, okay, this kind of question should be answered by the networking team, or this kind of question should be answered by the database team or some other team. So that way, the routing can be done very easily and very faster using this automated mechanism. Then live agents can focus more on, let's say, complex queries rather than the common ones, which can be very easily sorted out. But when we say this, again, building conversational experience has been always challenging. You need to understand what kind of dialogues or prompts can customers say. For example, someone can say, book a hotel for me, or someone else can say, I need a hotel. So when we are creating these kind of chatbots ourselves, right, we need to understand what kind of prompts or what kind of inputs the users can provide. So in some cases, the users can provide direct input which is already mapped in our chatbot, but sometimes it might not, right? So it was always difficult to identify or create a lot of options within our chatbot so that our bot is easily able to understand what the prompt is giving. You might have seen, like, sometimes you um, go to a customer service bot and then you try to ask a question and then the bot replies, I do not understand. Or you try to use different combinations, but if the bot is not intelligent enough, it will just keep on repeating the same, that I do not understand. Now, how to make that bot understand those things and even understand things which you have not mapped as a creator of that bot is what we are going to achieve using generative AI. Because generative AI will be able to automatically understand what the prompt is talking about, right? And you would have also learned about these things in the previous sessions, that how a prompt which we are providing to a generative AI model or a foundation model in that case will be able to identify itself, like the keywords, the verbs, and everything will be identifiable very easily. So that's why integrating bots with these generative AI services will be very useful. At the same time, let's say the user entered some abusive words, or the user entered some password by mistake. How will you ensure that the end agents, right, are not storing it somewhere? So the data privacy part is also challenging when we are building conversational bot, because we don't want our bots to share anything, right, like that. And optimizing the cost, integrating with the existing backends, so all those things has to be done individually. So that's why building conversational bots on its own was always a challenging part. But what we have now is Amazon Lex. So Amazon Lex is a conversational AI service which helps you to build these kind of chatbots very easily. So it's kind of automating a full business use case where you are just going to give some utterances, which is like the user inputs. Then you're going to create some mappings at the back end. You have different slots, and then at the end, the fulfillment happens. Is my screen still visible?
Yes, ma'am.
Okay, so moving ahead, what we have done is we are infusing generative AI into conversational AI. So what we have done is understanding the languages which the input is provided is very easy. The dialogue generation or the responses being provided is also generated automatically. The knowledge representation, for example, you can't add all the information in the bot, right? And what you want is, let's say you have a policy which should be used while answering the user questions. So if you want to do that, you have different kind of sources or internal links, repo links or anything which can be integrated to these chatbots, and then automatically the response will be given. Personality is another feature where you will be able to map or create different kinds of sessions for specific users, and it will be very easily map your chats to the specific user that way. So these were the strengths which we have when we use generative AI. And when we use conversational AI, in that case, predictable dialogue and control will be again given to the users who is actually creating it. Now let's go ahead and see how Amazon Lex powers complete solution, like the enterprise level solutions in that case. For example, if you want to have sophisticated conversations, right, you want to use specific generation of images. You want your bot to generate images as the user asked. You want your bot to maintain some dialogues and maintain sessions or maintain a personalized experience. So in that case also Amazon Lex help you to create that. You can also do transaction based interactions, right? You can have lambda functions. Integrated lambda is another service within AWS. It's a serverless service which helps you to run code in a serverless way. So that way you can integrate lambda functions as well and provide responses, run some business logic too. It's very easy to use. We have a complete console with few clicks, your bot is ready. And with the addition of new generative AI feature, which I'm going to talk about, it's just that just mention that I want to create a bot for hotel booking, and it will be done. So it's very easy now to create such kind of bots. Also for enterprise experience, we have integration of Amazon Lex with the Connect and few other services as well, like messaging services. And then you can perform operations based on that, and you can secure it at the enterprise level as well. Okay, so now comes the big thing, which is Amazon Lex powered by generative AI. So it's not that we have launched Amazon Lex just now. So Amazon Lex was launched in 2017. Then came Lex V2 with some advanced feature. Then we added IVR features like connection with specific services like Connect, and it was providing IVR features that way. Then we integrated 25 plus languages in there so that the IVR responses can be done in different languages. Then we also added visual conversation builder. For example, now you can just do a drag drop and create your whole bot in a very easy way. And then we also added analytics test workbench where you can analyze the workloads on your Lex bot. And now what we have is GenAI. Now, how GenAI has changed it, it has simplified the bot building process. So the use case design and build, test, and deploy has been very easy now. So the developer productivity has overall increased because they don't need to make a lot of changes while creating these kind of bots. So it's very easy to create those bots that way. It also increases the bot efficiencies by directly connecting to different sources and using Amazon Bedrock, which will help us to connect to different foundation models. So Amazon Bedrock is a service I'll talk about detail in some time as well, but it's a service which helps us to connect to different foundation models using an API. So just with an API, Amazon Lex will be able to connect to Bedrock, and Bedrock will be able to fetch the data, use generative AI to send the responses to the end users. And the responses can be either a voice response, a text response, or any other source which you want. Let's see a quick example of, let's say, you just want to create a bot for book a hotel, and you just say book a hotel on this particular bot. Now, automatically, the speech recognition will happen that where do you want to book a hotel? Let's say you have said book a hotel in NYC. So it will be able to understand that it has to trigger two different use cases like hotel booking and where New York City. So then we have to create some mappings at the back end of this Lex bot, and it will be able to fetch like which hotel bookings are available and which are the hotels available. So it can give you responses like choose from the below hotels, or give me the next date of your booking, or when are you checking in, check out, and number of guests. So all those details can be fetched very easily. And using Lambda functions, you can connect to your backend services like your databases, your API servers, your EC2 instances, or any other source which you want, your S3 bucket. So all those conversations can be happen directly. And finally, the confirmation can be given that your hotel is booked. Now, that confirmation, if you want it again in a speech format, you can use Amazon Poly, which will talk as like your hotel is booked for April 19th. So all these things are very easily done and very much possible directly through Amazon Lexbot. Okay, I don't see any question. Cool. I'll just move ahead. Okay, so before going into or diving deep into the Lex part, let's look at a basic of bot concepts within Lex, right? So what we have is initially is the intents. So intents is something which will help us to gather the user input, right, as well, and perform the action. So the user input will be utterances, that utterances spoken word, whichever the user input has been given, or that particular phrase. Intents is a mapping. So this utterances has came, we want to you do these kind of actions, that will be mapped via intent. Then we have slots. Slots are the input data. For example, let's say you have said book a hotel in New York City. The New York City is a slot which will represent the city. So we definitely need some keywords, right? So we will see in detail during the demo as well that we need some keywords which will be actually used to perform the operation. At the back end, definitely your application will be running. You have to run some API calls, but you need to fetch those values right from the user input. So those inputs are called slots. Then we have fulfillment mechanism, that is actually the final status. Once done, you want to send some messages to your user that your booking has been done, and then that is the end part of your chat history. And then again you can initiate that do you need some help again, or things like that. So that's a whole um, major constructs of a bot history completely. So that's how you can understand that how a bot will work. So I'll talk a lot about intents, utterances, slots, and fulfillment in coming slides as well as in the demo. But just understand that these are the types which we have within Lex. Okay. Now, the new feature which was launched with Amazon Lex was to increase developer productivity. So what we have done is we have created something called as descriptive bot builder and utterance generator. Now, let's say you want to create a bot and you don't know where to start. So once you integrate generative AI with your Amazon Lex, you allow basically in your AWS account that under Lex console, you mentioned that I want to build a descriptive bot. What it will just need is just tell the reason, just tell that I want to create a bot for this use case, and it will create a bot for you for some basic use case, right? Or with some basic intents, some slots created based on the understanding which it already has. It might be possible sometimes that what you are saying might need more information, but it's definitely it's editable. You can add more slots, you can add more intents, but it will be very easy to just add a description, get a bot ready, and then make the edits rather than starting from scratch and creating everything on your own. Next thing is utterance generator. As I was showing here, right? These are the utterances. Like I'd like to book a hotel. Someone can say I like to book some other source or book a hotel. or just say need a hotel on this date. So all these things are utterances. Now automatically if we start adding a lot of utterances on our Lexbot, it is very time consuming and it's subject to human errors because we might miss some utterances. And when we are talking to an actual user, actual human, they can say or pronounce it in a very different format. So what this generative AI capability with Lex will do is it will automatically help you to create more and more utterances so that your bot is capable of understanding those utterances. So it should be able to identify, okay, let's say uh, you said or a user said that book a hotel, but that utterance is not there. So it will give you an error if you don't use this or if you have not defined an utterance. But if you have already used utterance generator, it will help you to minimize this risk and then make sure that you're getting a lot of different inputs from the user at the same time. So utterance generator is another thing which you can do. Let's look how it actually does it. So if you can see here, while creating a bot and while choosing a bot type of descriptive bot builder, you are just telling them that we want a bot that will allow a customer to book hotels to any of our international locations. The bot needs to be able to allow them select the type of room, including accessible rooms, the length of stay, and other consideration like rates. So we are just giving this input to our descriptive bot builder, which is powered by GenAI. What it will do it will create some intents based on its own understanding and the backend foundation models. It will create some intents called like book hotel, get room rates, and also some slot types. So all this is automatically done just with a single message or a single click. This is actually very fascinating because you're not doing anything here, you're just mentioning your use case, and it has saved a lot of time for you to identify what kind of intents you need and what kind of slots you need. So it has already created it. Definitely you can go ahead, do some edits there, make some more changes, create some more intents if you want, and then create some more slot types. But the uptime of such applications is very fast because you're just giving the description and it's up. So you have a bot ready. It's I it isn't it cool, right? We are just writing one thing and it's creating a bot for us. We just need to do is deploy the bot, extract it, and integrate it with applications. Any question? Okay. So going ahead, I'm just going to show you how we actually have created this particular bot. So when we go to the Lex console, right? So we have different options. We can create a descriptive bot builder using GenAI, a blank bot. We can start with an example which already has a bot. Then we can start with the transcripts which already we want to upload an existing bot which we already had. So those kind of things can be done. So we can choose which type of bot we actually want. We will just select that thing and we will make some changes and it will create that. Just remember that you need to have Amazon Bedrock setup because it will use some pre-configured models and you have to enable access to those models and then do it. For example, here I have just mentioned that I want to create a bot like that. I'll just give the IAM permissions. We'll just check the policies there and we'll click on next and we'll choose if I am using some speech conversion. So I'll use that and then we'll add the description there, what all details I want in my bot, and then we'll create it. So it depends like which model you want to use. It also allows you to choose the different models. Here I'm using Anthropic model and the version will be Claude V2. So you can choose which specific model you want. Just remember that before starting using it, you have to enable those models in Bedrock because it will automatically connect to Bedrock to get those specific models. And it's done. So once the bot is done, we can see whether the intents created are right or not. If we want to create more intents, and then we'll confirm We'll also see some sample utterances which were created automatically using this descriptive bot, the slot types, and we will add all of these to our particular bot which we have created, and it should be done. So we just mention add to selection, and then we'll be done with bot creation. So intents and slot types are now created and already added. Similar to this, what we can do is we can do utterance generation. Now, initially, what we have mentioned that we want to create this particular bot with a specific type. So now what we want is we want to create more utterances. Now, utterance generation is another feature. By default, as I was telling you, right? You can add specific utterances, but if you want more and more utterances, you can ask your generative AI models to create those. So they the models are already trained and they already know like these are the similar words or these are the similar kind of keywords which can be used by a user to perform a specific action. So similar to that, it will start creating more and more utterances. We'll do that in the demo as well as in the workshop, but that's how you can do or generate the utterances. Just have to click on this and will create more and more utterances for you, and we'll add that to your particular bot. I hope utterances is clear. I saw um, a question around intent. So what intent is just trying to show you that the action which you want to perform. For example, book a hotel for me. Okay, that's an intent overall, and within that, this complete intent is a kind of part of an action being performed by the bot. Now, as soon as this utterance is coming in or the user is talking about this occurrence, the intent is triggered. Now, when the intent is triggered, you have different options of workflows, which we will see in a moment, workflow to perform. For example, let's say I have first asked them what is the room type you want, or first I want to ask them what is um, the date of check-in. So it can be in order which you want to perform the actions, right? So that complete thing is part of an intent. I'll show you different intents while we are working, but for now I think you can understand that the actions being performed by the bot or how you want to define the workflow is what intent is. Okay. Now, let's say for end user experience also, we have integrated GenAI with that. And how it helps is we have assisted slot resolution and we have conversational FAQ. Now, first, let me talk about assisted slot resolution. For example, let's say um, we'll see that example during our workshop as well. But let's say I tell the bot ask me, tell me the number of visitors, right, for whom we are booking the hotel. So and you say that me and my two children. So you are not giving a specific number there, right? We have to identify. If you don't use this slot resolution, it won't be able to calculate that me and my two children means that three people are going to stay. I hope you understand. Like when we are not talking in terms of direct figures and we want our values to be determined automatically using AI, then we use assisted slot resolution. So that's how it will be able to identify, okay, this means that three people are going to stay. So that's what assisted slot resolution means. And I'll show a demo as well for that. Now, next is conversational FAQ. Let's say the user is asking more information like what would be the weather in New York around these dates. Your bot cannot store all the information about the weather or the historical data or let's say common information which might be there. So in that case, what you actually need is a conversational FAQ. And here we will use RAG based solution and Bedrock knowledge bases, where we will add some information or we will link our bot to these RAG based solution and the models so that it can get the data and give the response. So feel free to post any questions. So I see a question around pricing. So Lex pricing is very well defined. It depends on the number of utterances and intents you use. So yes, a bit of free tier is available, but some integrations with GenAI and others are actually chargeable. I'll share the link in some time. Okay. The next question is how the RAG based chat application is different with conversational AI. So RAG based chat application is actually a part of that itself, where you are actually adding more and more information in between. Using RAG, you're trying to send the response. So it's actually part of that. Conversational AI is actually can be implemented using RAG based using RAG. So it's kind of the same thing. It's just that for this particular use case and for today's session, we are talking about Lex, which is an you can say managed service provided by AWS, which can be used to create conversational AI chatbot. Okay, um, let's move ahead with the next step then. So as you have seen, we talked about slot resolutions. So let's say these are the examples. Um, it will use the user's input to naturally understand that and map that to a specific data type. For example, a specific intent can have some check-in date, will get some location and the number of gets automatically, and will be able to add it directly. So that's what the slot resolution means. So how does the GenAI assisted one helps is it uses the foundation models like Anthropic, Cloud 2 and Cloud Instant. It first try to identify what is the particular phrase or the utterance which the user has provided. We'll try to get the slot values out of it, combine it automatically, try to understand it using an LP, and then add the final values. But we have to enable that feature for every slot. So if it's not enabled, then we won't be able to get that value. Now let's look how it is actually done. So if you see here, I'm just trying to make some changes to the current slots, and what we are actually doing is making changes to every slot so that it can help us to identify the values automatically. So in this case, if I go ahead and test this, and I mentioned that I want to book a hotel, so it will ask me which city and I'm providing that. So I just said I'm heading to London for a conference. I have not said that the city will be London, but it was able to identify it. Okay, so you can also see here that when you're talking about a specific utterance and you have just mentioned the particular date, and when you mention how many guests will be staying in the room, you was able to identify the slot values automatically and provide the response. So it was able to tell that only 3 people were staying there, right? So if you see this, how many nights will you be staying? So we have not mentioned a specific number. We're just saying Friday, Saturday, and Sunday night. And then we are just talking about the room, and then how many guests will be staying in the room. So that also will be identified automatically. So it just said that my wife and 2 children are staying, and that way we were able to map the values. Now these are the slots, and this is a complete intent which is focused on booking a hotel. We have named the intent as book hotel, and we have different slots which will require different values, and we are getting those values using the conversation. So this is actually a conversational bot which is trying to identify the values on its own and then sending it there. Any questions? Okay, so moving ahead, we already talked about a bit about Bedrock. That Bedrock will help us to accelerate the development of Gen AI applications. We are going to integrate that with different foundation models. With it can be Anthropic, Cohere, Meta, Amazon, AI 21 Labs. So different foundation models which already exist. We can link the models there. Then sorry, we also can customize these foundation models using our organizational data. Next, we will talk about different kinds of um, models which Bedrock provides. So Bedrock provides AI 21, Anthropic, and all of these differ in terms of the type, right? As I was telling initially, it can be text to text, it can be uh, text to image, and other things. So those kind of things can be changed. And what are the common approaches which we use for customizing the foundation model, right? So here comes the RAG feature as well. So we can use prompt engineering, like we are adding a lot of utterances, and based on utterances, we can make the changes. And then we can also use RAG, where we actually augment a lot of different knowledge, and we add some knowledge base separately, and that knowledge base will be used to actually perform the operation. Then we can use fine tuning the model further. Like, fine tuning might be a little tough because these foundation models are managed by different companies, and they are themselves trying to fine tune the model as and when they get more and more data, and then training the FM from scratch. So the complexity increases as we go ahead. Now we have already solved a bit of the complexity using Lex when we are using generative AI, and we are creating a lot of utterances, which is like we are improving our prompts. Next option we have is retrieval augmented generation, that is RAG, for customizing the responses. Now, there are two things which we can do. Either we can customize or we can augment. So, let's say you're trying to perform an operation or creating a chatbot, and you want to give realistic information that way. So, is the information real time, or you want to just ensure that it stays there? For example, there can be some reference links or repo links which already has some static information. You want to link those, so that way you can use knowledge bases. Now if you want some dynamic set of APIs, where let's say you want to see the current information or you want to get some dynamic data out of it, then you can use Bedrock agents as well. Now, if it's a simple task, you will just use prompt engineering to perform it. Or if it's a very complex task, then you will use fine tuning. So that's how you can decide whether you want to customize or augment the data. So what we are looking here is augmenting the data with RAG, where we are going to create knowledge bases, and that knowledge base will be used in your Lex bots as well. What does RAG means is we'll retrieve some information which is relevant to the specific bot use case. Then we'll add that information. We'll basically augment the context to the prompt which is going to the foundation model. Then we are going to generate the response. So that's how RAG will work in the overall scenario. Now let's see how it works in the conversational FAQ. So what conversational FAQ means, the queries which you are sending to the Lex bot. So let's say you are trying to ask a question like what was the weather in New York, that's one example, or which are the famous places to visit in New York. So all those things, your book a hotel intent might not know, right? But you don't want your user to go empty handed, or you don't want them to just get a response that I don't know that information. For that, instead of feeding everything in the particular bot or in the responses, hard coding those things, you can link to different pages or different public information or details about, let's say, New York City, and automatically these bots will be able to respond. Now that's what conversational FAQ means, and that's the addition which we have done in the existing Lex bot. So it can use RAG capabilities, it can provide contextual responses, it can also um, provide customized responses. For example, you can again ask like what was my booking ID. So all those things can be automatically identified using these conversational FAQ options. It also helps you to point to specific locations of your company. For example, your company has all the policies present in a specific location in an S3 bucket. So if anyone asks a question around policies, you want that bot to go to that S3 folder, fetch the responses from there, and get a relevant response and provide it. So that's how you can interact with a conversational bot and use FAQs there. Then you can also integrate it with knowledge bases which are already there for Bedrock, Canva, and OpenSearch. So you can mention while you're creating that bot, you can create your knowledge base. I'll show you how we will do it there, but you can test your draft version of your specific Lexbot, integrate your Bedrock knowledge base with your Lexbot, and the Lexbot will be automatically will be able to fetch the data from there and provide the response. For example, on the screen you can see the options of what are the differences in amenities between Miami and this other location. So all those things can be already present in your knowledge base or some references, and it can be fetched and provided. So that's all. We'll start with a demo, but before that, any question from anyone? Okay. If no questions, I'll just share a particular um, workshop which you can also try at your end. If you want to try it later, you can try that, and I'll just walk you through the complete workshop. We'll show some demo as well there, which I've already done for this particular workshop. Let me share that screen. Okay, so this is a specific workshop which we are going to review today. This workshop intends to help you understand building Amazon Lex with generative AI features. So I'll talk to you about what assisted slot resolution is, what utterance generation is, and we'll show you all those things, as well as we'll show you how it looks at the specific, you can say, how it actually looks in the Lex console. Okay, so what we are going to do here is we are going to create a Lex bot with different slots, different intents, using generative AI. So the first step to actually do it is requesting the model access. So what we do is whenever we want to integrate Lex with Bedrock, we need to ensure that specific models which we are going to reference are actually present in that particular bot. Is my screen visible?
No, Pallavi.
Okay, let me share. Let me know once it's visible. Okay, it's there. Cool. So this is the workshop which we are going to conduct today. It's 300 level workshop, and it has certain duration as well. And I'm just going to walk you through this workshop. Its workshop link is already available. I'll share it with you as well, and post that you can try and create your own chatbots whichever way you want. What the first step of doing this workshop is, we have to request model access. So model access is important because our Lex bots will be connected to Bedrock, and Bedrock will be able to fetch information from different foundation models. And to do that, it needs access to different models, right? So what we have to do is, we have to go to Amazon Bedrock. We have to select specific model. So we have to go to left navigation pane, then choose model access and choose the specific models. Here for this particular workshop, we are using these models, and it's totally on your choice which kind of models you want. You can choose those models to perform the operations. And while linking your export to Bedrock as well, you can choose which models you want. So there are multiple models already available within Bedrock, and you can choose that. So that's the first step. And once access is granted, the next step is to actually identify how your bot will look like. For example, in this particular demo, I'm going to show you a bot which will be used for booking a hotel at a specific location, right? So I already have a script written which tells me that what are the utterances I need to do. So these are the utterances which I'm going to use to enter in my chatbot, and my chatbot will start replying based on that. Okay, for example, I will mention I want to book a hotel room and what city and everything. So whenever you are trying to create a bot, you should know what kind of responses you want. So try to create a dummy script using which you will be able to create more and more intense utterances, and you will know what's required and what's not. So this is the first start of that. Now, once this is done, we just have to create a bot. So as I already showed you, will create a descriptive bot. We'll create some slots. We'll generate some utterances. We'll also use Visual Builder to perform that. And then we'll use assisted slot resolution. And if needed, we'll add some Lambda functions as well to update the booking in the DynamoDB. So this is a self-paced workshop. So the first step which we're going to do is go to Amazon Lex and we'll create a bot. So let me show you how we can actually do it. So this is the Lex console, which you can just search for Lex in your AWS account, and you will be able to identify and create the bots there. So just click on create bot. So these are different options which are present. So you can see you can create a blank bot where you just will create the bot, and you'll have to create all the slots and intents yourself. You can start with an example where already a book trip bot is created with this type. So this will also help you to understand what kind of bots can be created within Lex. You can start with some transcripts. You can add some transcript already present there, like these, and this is a transcript of a conversation of with a bot, and it will create it that way. So what we are going to do is, we're just going to create descriptive bot builder. We are going to use it. It's a GenAI feature. You'll see this link or this kind of icon for GenAI features, which can be directly used. You can just give the bot name, the description, and it should create the bot. How it actually do is, you'll select this option, then you'll give a bot name, book hotel, and then you'll choose the IAM permissions. Okay, create a role with basic Amazon Lex permissions. You'll select this, and then you'll be able to add some language, whether you want the bot to respond in English. You can choose different languages there as well, and that's it. You can choose a voice, whether you want to, there are different types of voices already provided within Lex, so you can choose what type of voice you want your Lex bot to respond with. And then for generation input prompt, so you can mention that you want a bot which can do these options. So the bot should be able to make hotel reservation and handle canceling reservations as well. The bot should have the following intents and slots. So you can mention that you want these kind of intents, you want these kind of slots. Even if you don't mention, it will create some defined ones. Then once done, it will be able to create a bot for you, right? So you can just mention you want these. You can mention which model you want, so it can be Anthropic, it can be any other model, and done. So once done, you should be able to review the configuration, right? So here is the generative AI configuration. Now right now I have assisted slot resolution as disabled, and also the sample utterance is disabled. But when we actually have to go ahead and create these kind of stuff, we have to enable them, right? So you'll see that descriptive bot builder, the status, you can click on view details, and you'll be able to see what are the intents which were generated. So we already had a book hotel, cancel reservation, and we already had a slot type as well. So how it looks like is, let me show you the bot which I used using descriptive bot builder. So I created this book hotel new, and it already has a lot of different features. Let's go to intents, and I can see there are different intents. So you can see intents is the action. For example, book hotel. So this will contain all the options or actions I require for booking a hotel. So this is what book hotel intent means. And once the intent is already created, we'll be able to see what are the slots values present there and other details. So you can see it here, the intent is created and the utterances are already added. So can you find accommodation in this, from this to this date and number of nights? So this can be one occurrence. So let's say if a user mentioned that I need a hotel room in um, Mumbai. So city will be Mumbai here for 5 nights starting on 20th of July. So automatically this occurrence will have different slot values. Slot values are nothing else but the keywords which you want to pass. So it can be city, number of nights, check-in date. But these values can be provided using different types of utterances. So that's why we have multiple utterances mentioned here. It can be reserve a hotel in this city from this date for this many nights for this many guests. So it can be a simple single line utterance as well, or multi-line utterance as well. So just understand the difference between utterances, because your user base is going to be a big one where users are actually going to perform a lot of operations, can say a different kind of keywords while generating or interacting with your chatbot. So that's why it's important to create multiple utterances in the beginning. We have also created slots. Slots are the actual values which we need for that operation. So we have created check-in date, city, number of guests, number of nights, and room type. And slot types is something which you can define. For example, Amazon Lex provides you options for different slot type. It can be Amazon.date. So it's pre-defined that it will be mapped as a date value. It can be a city value. There are multiple cities already present. It can be a number, or it can be room type values. Room type is something which you can define. You can define whether it needs to be a king size room, a queen size room, or any other. So that's how you can define that. Once done, you can confirm the intents and slot type, and it's already created. For example, this particular intent has been already created. This is the conversation flow which we are going to use. And then context, if you want to write the sample utterances. Now these are the sample utterances which already came. If we want to generate more utterances, we will just create on generate utterance, and you'll see more utterances will be automatically added here. So that's how you can keep on modifying your particular Lex bot. So it will add more utterances now. Similarly, slots. So you can have different slot types which you can define, and you can make changes or customize those slot types as well. Any question with the basic first creation of chatbot? Feel free to pose a question. I can answer in between. Okay, so once this is done, once that bot is created, the slot is created, what we will next do is making some changes. So as I was saying, right, we have some slots values already defined. We have something for date, we have something for number as well. But for example, I have a slot type as room value, right? So I want to define that it can be king, queen, or two queen beds. So, or can add some synonyms as well. So all of these things can also be done, and I can define some custom slots too. After that, what we can do is we can do utterance generation, which I've already showed you how to generate the utterances. Just ensure that you have enabled that, because until and unless you enable this for your specific intent, it has to be done per intent wise. Once done, then only it will connect to GenAI and do that. How does a chatbot look to end user? Okay, so once this chatbot is created, you can integrate it, you can create some versions and alias. So it will be a URL kind of format, and you can integrate this chatbot to your mobile applications directly. So the UI customization completely dependent upon the users. So but once the chatbot is created, you can just integrate it to different sources. It can be integrated via Facebook, via some other messaging services, Android or iOS, and all those stuff. So it's just that create the chatbot here and integrate it with your specific application where you want. So there was a question around how does the chatbot look to end user. So once you integrate it to your specific user base or to your applications, it totally depends there. But I'll show you how it will look like when we test it in a moment, once we start testing it, right? This is already there, and if we start testing it, we'll be able to see how it looks like. So this is how I want to book a hotel room. So it's just asking me which city. So I'm going to give some prompts, and it will be able to identify it. So this is a local test version you have on Amazon Lex, but once you actually deploy it to your application, the UI is customizable. So you can use that. Okay, moving ahead. So we have already added, created the bot. We have added more utterances. So what we'll do is we'll select a specific intent. We'll generate more utterances there. So if you want to generate more instances, it will do more, but at a specific time it generates 5 utterances, right? So it's also mentioned there based on your intent name and other things. So it will automatically generate. Just remember, all this is happening via generative AI, so it's all being done automatically. You don't have to worry about different kinds of utterances in that case. So it already added more interest utterances, like I want to book a hotel, I want to book a hotel in this city. So that's how it is. Once this is done, what you can do is you can design your bot using a conversation builder, right? Visual conversation builder. So how we do it is we go to the intent, and you have this option there as visual builder. Just select that. Let me save the intent first, and then I should be okay. So I'm just saving the intent, and I should be able to go to Visual Builder. So Visual Builder is some, you can consider it as a feature of Lex, which is actually allowing you to make some changes and add more features in your particular intent. So our intent is now saved. Let's go to Visual Builder. You saw, right? The once it was building it, it was not ready for testing, but it automatically got ready once the build was successful. So how it looks like is this. So you have editor, which is like manual steps you have to follow, or you can use Visual Builder. So in the Visual Builder, you have different slots already defined. Like this is the workflow. So first step can be invoking a Lambda, or which city, like you are trying to get the city value and other things. Let me show it here. Okay. Just expanding it a little bit so that everyone can view it. So if you can see, the first one is this is a workflow. So this is a start where a user can say, help me book a hotel. Then we'll get this slot value of city. This is one slot. On success of the slot, we are going to another slot, which is check-in date, and so on. Like next, we are going to number of nights, then room type, and provider comments and others. So these are different actions which you have added. Now, this visual builder helps you to add more slots if needed. So let's say if I need another slot, so I'll just drag and drop this. I can make changes that after check-in date, I want to ask, let's say, gender of the person who is booking, or the phone number I want to get. So I'll just add another slot, and what I'll do is I'll edit it. I'll just give the name as ask phone number. Okay, I can give any name there. Let me write phone, and I can add description, I can add slot type. It will be a number, so it can be Amazon dot number as well. Okay, or we also have something as phone number, which is actually automatic validation. It will check what kind of number is being provided. So that's how you can do. So this is how easy you can create new slots. You can enable different things there, and then you can mention the slot prompt as well, that please provide your contact number. So that's how you can design your complete bot in that way. So with Lex, it's very easy to create the bots. You just have to mention what kind of values you expect, what kind of action you want, and the next option. For now, let me just delete this one because it's not part of our complete workflow, but this is how you can define. And let's say this is the link which I've already added. You want to link it to some other workflow. Let's say after city, you want to first get the number of nights. You can make the workflow changes there. Okay, so this is what Visual Builder is all about. Now, let's say you want to add more utterances or more prompt here. So, prompt is something that how your bot will respond to. Let's say someone has already given you the check-in date. What is the next question you are going to ask? So, that is what the prompt is. So, I've already given this prompt, and I can add more prompts by just going there. I can mention what date will you be checking in, when will you check in. You can say things like tomorrow, next Wednesday, or any other specific date. So all those things can be mentioned there. And I have also selected this, that play the messages in order, because I want to follow that particular order. I want to first get the city, then the check-in date, then the number of nights, and so on. So that's how I want to do it. So that's how you can define your complete workflow. Once this part is also done, the next option is to have assisted slot resolution. Okay, so as I was showing during the presentation as well, if we used to tell that how many guests will be staying in the room, and I just mentioned me, my wife, and our two kids, so this is not a definite value. And to identify this, if we don't use assisted slot resolution, that is a GenAI feature, your bot will not respond. Your bot will just say, please repeat, or I do not understand, and give me the complete number keyword for how many guests will be staying in the room. But since we are using assisted slot resolution feature, it was able to identify the number and mapped it to the slot value. So the number of guests was automatically changed to 4. Similar to this, we have asked like how many days or the number of nights. We just mentioned Friday, Saturday, and Sunday night. We have not mentioned the exact number. So this also has been automatically identified using the GenAI feature, and it changed it to number of nights. Now, how we enable it is we go to any of a specific slot. Let's say we go to this slot, we go on edit for the slot, and we enable it from there. So just remember, you have to enable it for every slot if you want. If you don't want it for every slot and you want that your user should provide a specific input only, you can unselect it. So that's how it can be done. Anyone has any questions around this? Okay. So once this is also done, what we do next is bot fulfillment. So bot fulfillment means that let's say we want to integrate this with AWS Lambda function. We want to trigger AWS Lambda to store something in database or to run a specific code. Okay. So that's what we can actually do using this. So what we'll do is we can add additional uh, hook here, like code hook. So code hook is something as lambda. So code hook just invoke a lambda function. We can say if this lambda function succeeds, what to do, if this fails, what to do, and if it's timeout, what to do. You need to know a little bit of lambda to actually perform this operation, but you can just attach it. Let's say sometimes you as a you are part of a team who's just responsible for Lexbot, so you just have to know the lambda function which is going to be invoked, and you should know where that fits in the complete workflow for your Lexbot, and then that's done. So once that is done, you don't need to worry about anything else. But within lambda function, what you can do is you can run your specific codes. You can create the function and run the code. Let me just quickly show you lambda as well, just for your reference. We are not going to dive deep on lambda, but it's very easy to use. You can go ahead and explore the lambda functions yourself, and feel free to let us know if you face any issue. Feel free to post any questions, team. It's important to understand different features of Lex and how they are being used, and yeah, I'm happy to answer it. So in the Lambda console, we'll be able to create the Lambda function and run a code. So let's say um, we can see here itself like how it actually works. We just create a function, we write the code, and whenever we invoke that Lambda function or we trigger that Lambda function, it will be automatically run. So you don't need a server for that. It's fully serverless. An execution environment is created at the backend by AWS itself, and you can choose which type of code you want. So for example, let me show you. Just create a function from scratch. Just mention what kind of runtime you want for creating the function, write the code for that, and just execute it when needed. So that's how you can create the function, get the ARN, and just add it here so that your Lex bot will be able to invoke that function. The code will run on that lambda function, will get the response and done. So that's what is happening in this particular workshop as well. You can define or you can create the function and let your lambda function run that way, and then we'll get the required response. So this is the lambda. It will be invoked by a specific alias of Lexbot and will be performed an operation will perform. You can add the code within your Lambda function and it should be done. Next thing is that you can also integrate your Lexbots with Amazon Connect. Before moving there, I would like to finish on the conversational FAQ section. So this is important. If you are interested for IVR setup and integrating Lex with Connect, you can use this option as well for integrate with Amazon Connect. Now let's look at conversational FAQ. What it does is here we are using some uh, data chunk or RAG based solution and Bedrock knowledge bases. So what we'll have is we have some data sources. We are already storing that in a vector database, and we are asking a Lex bot to connect to Bedrock and fetch the data from that vector databases. So what we are going to do is we are going to create an S3 bucket. Okay, first. So this S3 bucket will be able to store the references which we want our Lexbot to use. So what we are doing here is we are creating a bucket with a very unique name, and then we are adding our own file on that bucket. So this is how easily you can just create your bucket, and once the bucket is created, you can go ahead, view the details and upload different files which you want there. Now next option is uploading a file. So now here what I am doing is there is a file which already contains a lot of information. For example, what are the check-in and check-in out times, checkout times. So this can be uh, different for different types of hotel. So let's say the user is actually booking a specific hotel called fictitious hotels, right? So in that case, if a user asks a follow-up question and how you want to do it, so in that case you can just upload this particular file, use it in the knowledge base, and your chatbot will be able to retrieve the information from there. Questions like, do you offer airport shuttles? You can get different responses from there. Is parking available? What is the daily parking fee? So these are generic questions for which you don't have to do any computation, right? So that's why we are using RAG and knowledge base there. If we needed to use some kind of dynamic data, as I was mentioning, you can use Bedrock agents in that case. So once done, just upload this particular file to S3 using the S3 upload feature. You can use the console or CLI to upload your files to a specific S3 bucket locations. And once that is done, you will be able to reference it. Now, this is the only thing which you have to do on S3. The next thing which you have to do is on the Bedrock side. So what we'll do is we'll create a Bedrock knowledge base. So we'll go to Bedrock console. We'll select the models which we want, which we have already done for this particular use case. We go to knowledge bases and we create a knowledge base. Now here, while creating a knowledge base, what we are doing is we are going to connect to our S3 bucket and giving location of that bucket where that particular files are present. Now we are just giving location of the S3 bucket, so all the files which are present in there will be able to reference there. So we are connecting to the data source, which is S3 bucket, and it contains the content which you have already uploaded. So we are connecting our Bedrock knowledge base to that particular S3 bucket as a data source. So once this is done, what we will do is we will create a vector database then, and that vector database will be able to identify or create the embeddings specific to those knowledge base content. So now once this is done, the vector database will be used for runtime operations on that particular knowledge base. So I hope vector database you understand. So it's just nothing but it helps you to store the embeddings with respect to the data which you are using in your knowledge base. So we are selecting the embedding model, we are creating it, and once the knowledge base creation is completed, we will sync it to ensure that all the files are in sync. If we have uploaded any new file as well in S3, it should be properly synced. So once this is done and the data is also synced from the knowledge base, we will test it. So under the knowledge base itself, we can ask some questions and we will be able to understand whether the knowledge base is able to give us a response or not. So it's important to test it here and then link it to Lexbot so that if any issues occur If a knowledge base was not created properly, if the data is not referenced properly, you should be able to identify. So here I'm just asking whether it's a complimentary service, whether the parking is available or not, and then I'm getting the response. So this is how you can test your knowledge bases within Bedrock. You can select the model as well by default, which you want to use. Once this is done, you can add the RAG Q&A intent to Lex. So that particular intent where we have added a knowledge base can be added. So hey, what you can do is you can go to your particular bot, go to the intents, and then add the specific intent which is for GenAI feature, and that is Q&A intent. Now remember, what initially we were doing is booking a hotel, so that was a different intent. Now we are using a different intent. So if this intent will have different utterances, if those utterances are invoked, then this particular intent is automatically invoked. And what this intent is using is knowledge bases. So for different actions within your bot, what you can do is you can create different intents. That's how the whole flow of a chatbot will work. You can give specific knowledge base ID. You can link that particular knowledge base from the Lexbot to your Bedrock, and once done you can start testing it. So you can test and you can get the confidence threshold as well, and you'll be able to see that your bot is now able to perform different operations and will be able to answer queries which are based on the content which you have posted in Bedrock knowledge base. So once it's linked, it's done. Any question? Okay, let me show you and dive deep a little bit on knowledge bases as well. So when we are talking about knowledge base, right? What knowledge base is? From our Bedrock, let's say we have some policies associated with it, or a chatbot which we are creating would like to reference information from different sources. Okay, it can be a policy document of our company, it can be an employee data for our company, or it can be your own confidential notes, right? So those notes are present somewhere in some files. Now you want, if a user asks a question, they should be able to get the answer from this specific locations or from these particular files. Because when we are targeting foundation models, right, foundation models will not know anything about your company policies, because we have not used that data to train these foundation models, right? So in that case, if you actually want to use a specific data which your company is using, or which your personal usage, if you have any specific data which you want to use, so that way we create knowledge bases. Okay, so it will help the specific bot or overall GenAI functionality to get the data from different sources and present it. Because just remember that the foundation models are trained on a specific data. They will not know what's actually happening in your company policy, and we don't want hallucination based on that, because by default the bot will answer something or the other. So to ensure that we get the correct answer, we get the answer which matches our internal policies, we use knowledge base. I saw that question, so I hope it's clear about the knowledge base. So this is how we can create knowledge bases within Bedrock. So what we are saying, that the API calls which are being made, that should reference specific data sources. And I'm already mentioning a data source which is an S3 bucket, where I have uploaded specific files, and those files are actually referenced and giving me the output. Let's see if I select a model, this one, and I apply, and I try to ask a question from this particular knowledge base here, we can do it. So I have to sync my data source as well from time to time. So whenever this data source comes up, I have to ensure that I sync that as well. Any other questions? So I'm just syncing my data source, so that ensures that the file is not changed or anything else has not changed there. So that's why a sync is important. Okay, so you can see that I've already synced and I have a lot of informations there, right? So let me just ask some question from here and let me see if it's giving me the answer. Just trying to retrieve and generate the response. Okay, so you can see parking is available at most of these hotels. It has given the details. It has also shown you the source details. So it is showing the details here. Show source details, right? So we are just mentioning that was the source chunk. So that's how you can test your knowledge bases to ensure that whether the right response is being returned or not. So this was already present in the file which I've uploaded. So it contains there. So that's how I got the data. Now let's say if I ask any other question which is not in the file. Let me ask a question which is not there. Let's test it together. So it's saying that it has pools. That means that information has also been provided here. Let's try to see if it's provided or it's hallucinating or giving the wrong answer. Okay, it says that it has pool available. So that information was also already present in that particular hotel. So similarly, you can try to test a lot of different things and do that. Okay, it has a lot of different informations which you can test. I see another question. When it will take from KB, do you enable disable toggle button? Yes, so it's not actually enabling or disabling. What we are actually doing is when we are adding this Q&A intent, right, to the knowledge base, we have to mention that. So we are creating this intent and we are adding this feature that Amazon.Q&A intent. It's a GenAI feature. Okay, so we are using this type of built-in intent. So once done, we are also mentioning that what kind of knowledge base we are using. So we are giving this knowledge base ID. So while creating that lexbot, right, so you have to mention which knowledge bases you want, and if you want this intent to connect to that particular knowledge base, you have to mention the knowledge base ID. So once that is done, the link is done and it's good to go. Once done, you just build the bot and start testing. So that's how you create a link between your Lexbot or your intent to your knowledge bases. So it's not that there's a toggle button, but you actually have to mention the knowledge base ID and you have to tell that Lexbot should connect to this knowledge base ID for that. Okay. There is another question which is like, can we write Java based codes also in AWS Generative AI services? Sorry, I did not understand about that. Okay. So, what actually this is these are predefined or you can say managed services. Now, managed services, you are just seeing that most of the things are already being done. Now, once those are done, if you want to connect those or perform any operation using a Lambda function, which I have shown you, and there if you want to use Java based code, you can do it. But for these services, it's usually a configuration which you have to do. That's why we have made it simpler, right? Because these generative AI services, we you just have to make the configuration changes, attach it to some other sources, and then done. So you don't have to write in specific code until and unless you want to perform any business logic, but that will be external to this service, right? It's not like within this you have to write any code. No, it's fully managed. It's just a procedure or configuration you have to change, and done. So no code is needed here. You also are not training the model yourself. You are just using generative AI foundation models which are pre-trained, so that training is also not required here. Okay, I think we can take the next question. Okay, I think I've answered this one. When it will take from KB, do you enable disable toggle button? We don't enable disable. We just try to link it using the knowledge base ID, and we ensure that the intent can talk to knowledge bases. Okay, so the knowledge base needs to be converted to vector first. Yes. So if you've seen here, when we were creating the Bedrock knowledge base, right? What we did was, while creating it, we also selected that particular vector database which we want, and the embeddings were created. So that's why when you'll see that when you're creating the knowledge base, it will just take a little bit of time, because it is actually creating the embeddings for the data which you have given, or the resources which you have given. So it will automatically do that. You don't have to worry about it. You just have to select the vector database so that the embeddings can be stored there. And that's how Bedrock makes things simpler, because you don't have to create embedding separately. It will automatically create that, and it will create a new vector store. You can choose if you have an existing vector store or you want to create a new one, and which model you want to use for creating the embedding, because embeddings can be created in different formats by different models. So just select that and it will be created. So that's how we can do the vector search. Any other question, team? Feel free to ask any other question as well, if it's related to any other Gen AI topic as well. I'm happy to answer those. But I hope you understood about how a Lex bot is making things simpler for creating a chatbot. This is actually using conversational AI in the most simplest form, because Lex is already a service which is used for creating chatbots, and when we are integrating Gen AI with that, it's making things much simpler. Okay, I'll wait for more question. Okay, for vector storing, are we depending on relational, non-relational? Okay, we have different types of vector databases available actually. So these databases, it totally depends. Basically, what we are doing is we are creating a something that is highly performant, and it can be NoSQL or relational, and it should have additional capabilities as well. It can store, index, and query fast, right? you can use vector databases like OpenSearch. We have OpenSearch, Serverless, Redshift, and few others as well. Even PostgreSQL, like RDS PostgreSQL. So it totally depends how you want to create. We have very common vector databases like OpenSearch, which customers are heavily using. A lot of variety is available, so customers are it totally depend on the customer which one they want to use. So there are different ways how you can actually um, create these chatbots, and it's very easy to just use them and integrate them with different platforms that we can do. Okay, let me show not a running example. So the question we have next is, how do we integrate this chatbot with other applications? So there are different ways how you can integrate this Lexbot, right? So once you have the Lexbot, you have to deploy it, and once it's deployed, you can add it to different platforms. So you can add it to mobile applications using services like Amplify and others, and then you can also integrate it with Facebook, Slack, Twilio, others. So what you can do is, once this is done, you also need something on the other side, right? That application side. So you have to create a Facebook application. You need to get different integration parameters. So for example, once created, you need to get the app secret and the page access token for your application where you actually want to deploy this particular bot. And then once done, you have to add all these details, like which channel you want to add, which Facebook page you want to add it there, which application. And once all these details are actually provided, let me show these details. Just zooming in a little bit. Yeah. So if you see, if we add all these details, we add the description, how we want to add it to a specific channel, and you mention all those things. And once done and once activated, you can test the integration. So you can integrate that using that. Similarly, you can integrate it with Cake, you can integrate it with Slack as well, and you'll be able to make the changes. Let me show you here. Once done, you can activate and you can complete the Slack integration. So it totally depends which application you use, and once done, you can make the changes. Majorly, it can be integrated with this applications. If not, then what you can do is you can export the complete bot, use it in your custom applications in a different way. So that totally depends on the user how you want to integrate that. Similarly, you can do it in mobile applications as well. You can migrate a bot from one source to another as well, and you can import a bot too from different sources. You can integrate it with Connect to have some call center agent assistant. So you can have Amazon Connect integrated with it. So what happens is, as soon as a user integrates talk to Lex, it will talk to Kendra, it will talk to S3, and you can add GenAI features as well in between, and then respond back. So Lex has always been used in different sources to create chatbot. We are just increasing the relativity or increasing the performance and features using generative AI. So this is in the public documentations, very easily available. So if you want, you can go ahead and explore these options. Any other question? Feel free to ask any questions. We still have 10 minutes. Okay, seems like no question. I would highly encourage you all to please go ahead, look at the Lexbot configurations. I'll also share um, the workshop link. Should be public. Let me just share it with the team so that they can share it with others, and you can go ahead and look at the workshop. Okay. Thanks a lot. Thanks a lot for listening, and apologies for the in between network issues. And I've just had a little bit of bad throat as well. But feel free to reach out to me separately as well if you face any issues. And very much interested to be part of this generative AI framework and all these exercises and sessions which you all have been doing. It was really interesting to be part of it. Thank you all.
Thank you so much, Pallavi, for the insightful session. Your expertise has greatly enhanced our understanding of these complex topics. The practical hands on experience with AWS Lex and Bedrock was particularly valuable. Now, if you don't mind, we have an exciting announcement to make. Uh, we are excited to announce the best performers of the bootcamp so far. Your dedication and hard work have not gone unnoticed. These are the names of the best performers: Sumbul, Rupa, Shruti, Vijay Raghavan, Siddhi, Aman, Parneet, Nandini, Prachita, Asma, Shishir, Lavanya, Francis, Amelia, Hitesh, P. Harsha Priya, Kshitij, and Jyotish. The star performers will be informed about their awards soon. Congratulations to all the top performers. Keep up the great work and continue striving for excellence. We will also be announcing the best Party Rock apps soon, and those whose names are not here, don't worry. Make your upcoming submissions and get your chance. Now, for the post session activity, share your learnings and create a simple chatbot. Share a demo with us on LinkedIn, write a blog, or create a video of 30 to 60 seconds. A form link will be provided to you after the session for submission with all the instructions. To ensure your attendance in the session, you can scan the QR or fill the form given in the chat. While you all mark your attendance, there is one more important announcement. As we approach the end of this AWS Generative AI Bootcamp, I hope you have found these sessions insightful and engaging. As we gear up for the final project presentations, it's time to finalize your teams if you haven't already. Choose any simple problem and apply any GenAI service to develop your solution. Collaborate, innovate, and utilize the knowledge you have gained throughout this bootcamp. I look forward to seeing your creative and practical implementations on the last day. Good luck, and let's make this final presentations remarkable. And if you have not marked your attendance, you can just simply take a screenshot or fill the attendance through the Google form. The attendance form will be closed soon. Lastly, and the most important part, remember to complete your tasks before the next session. Share your progress and reflections with the community to enhance your learning experience. We will be sharing a form in the WhatsApp group for you to submit your tasks. So make sure to complete your tasks promptly. Thank you all for your enthusiastic engagement throughout the session. We trust that your questions have been thoroughly addressed and that you have found value in our discussions. We have more exciting sessions lined up, so stay tuned for the updates. Follow us on our social media handles for the latest news and events. Below in the description, you can find the link to Twitter, LinkedIn, and Instagram to connect with us. Thank you once again to all the active participants. Let's continue the story together to make the most of what AWS and generative AI have to offer. Have a great day, everyone. See you on July 19th at 5 p.m. on the same platform.